Hi, welcome to the last of the videos on section 1.2. This is video 1.2c, end of limits graphically. So we're looking at pages, in the book on section 1.2, exercises 29 and 30. Sketch the graph of f, then identify the value c for which the limit is x approaches c of f of x exists. So we're going to be looking at number 30. First of all, you'll notice it's a piece function. This is done by hand. There's no symbol over here that says we're doing it with a calculator. We'll come back to that later. But doing it by hand, you have three different functions, and you'll be graphing them in three different locations. So you'll be graphing y equals sine of x, but only the part of it to the left of 0. You'll be graphing 1 minus cos x, but only between x equals 0 and pi. And then to the right of pi, you'll be graphing cosine of x. Now notice what it's asking you is identify the value of c for which the limit as x approaches c of f of x exists. Now remember, this is a two-sided limit. The only way that's going to exist is if the two one-sided limits on either side of c exist. Now, sine x, 1 minus cos x, those basic graphs don't have any discontinuities whatsoever. The graph is smooth. So really, the only potential place they might not connect, and therefore the two limits on either side might be different, would be at 0 and at pi. Okay, so starting with y equals sine x, here's the graph of y equals sine x, but we're only graphing it to the left of 0. So we're only graphing that red part. Notice it's an open dot here because that's just a less than sign. And what I'm labeling over here on the right in green are the endpoints of each piece. This will be an open dot at 0, 0. Let's go down to cosine x. Cosine x, of course, is this graph right here, but we're only graphing it to the right of pi. So that would be this little piece right here, just to the right of pi, comma, -1. Again, that'll be an open dot because there's no equals, and that point would have been the point pi, -1. 1 minus cos x, what we do is if you go up here, if this, of course, is this green graph is the graph of y equals cos x, then y equals negative cos x, you'll flip it over the x-axis, and then you'll move it up 1. So this point here, which is 0, -1, will now be at 0, 0. This point here, which was at pi 1, will now be at pi, 2. So, and we're only graphing this graph between 0 and pi, which is this blue portion. Now, these are equal signs. These two will be filled in dots. That's the point 0, 0. And as we said, that's the point pi, 2. So, when it's all said and done, we now have the following. Okay, now the only reason I've put the unit circle over here is for those of you that have a little trouble remembering what's what, but remember at 0, the cosine of 0 is 1, the sine of 0 is 0. At 90 degrees, which is pi over 2, the cosine is 0, the sine is 1, etc. So here is our piece function graph. The question is there anywhere where the limit from both sides of a particular number does not exist? So you'll notice this is all smooth, so no matter where I am, it's approaching the same number from both sides, including here from the left at 0 and from the right at 0, the limits are both 0. The only place where the limit from the left as x approaches a number and the limit from the right as x approaches that same number are different is these 2 points right here. So as you can see from those 2 points right here, we have that the limit as x approaches pi does not exist. And the reason is because the limit as x approaches pi from the left, which is 2, does not equal the limit as x approaches pi from the right, which is -1. So the limit as x approaches c of f of x exists for all real numbers except c. And of course, there's different ways to write that: interval notation, set builder notation, or regular inequality notation. But do be careful you don't answer pi. They didn't ask where it didn't exist. They asked for all the numbers where it does exist, and that's everywhere except pi. Okay, number 32, on the other hand, here's the question. It says, in exercises 31 and 32, sketch a graph of the function f, again without calculator, that satisfies the given value. And of course, there are many correct answers, so when you look at the answers at the back of the book for questions like this, they just give one sample thing. So they're giving you 4 conditions, although they are giving you a fifth by telling you it is a function. So remember, you cannot have any 2 points with the same x and different y's. That wouldn't be a function. So to say that f of negative 2 equals 0 is to simply say that the point negative 2, 0 is on f. And let me fix that because that is not quite clear and is on f. Okay. Then what we have is f of 2 equals 0 means the point 2, 0 is on the graph of f. If it says the limit as x approaches negative 2 of f of x is equal to 0, then that's telling you that the two one-sided limits, both from the left at negative 2 and from the right at negative 2, are both 0. It tells you nothing about what happens at negative 2. This is what tells you what happens at negative 2. Then goes on to say the limit as x approaches 2 from both sides of f of x does not exist. Well, that could be a few different things. That could be a what we call, and we'll talk about that later, that could be a jump discontinuity, like here, where the graph jumps from one height to the next. So it is possible. Or it could be an infinite discontinuity, which means there could be a vertical asymptote there. And as you can see, the limit from the right would be infinity, limit from the left would be negative infinity. So some of the possible graphs could be all of these different graphs. Keep in mind that these 2 points have to be on the actual function. So this is a possible graph. There's the 2 points. There's the limit as x approaches negative 2 from both sides is 0, and the limit as x approaches 2 from both sides doesn't exist. Same thing here, same thing here. The reason this one is no good, hopefully you can tell, because that's not a function. You cannot have 2 points on the same vertical line. And that's the end of section video 1.2c. It's also the end of section 1.2.